In this video, we are going to solve a very simple problem based on periodic properties. Among the following pentachlorides, the one which does not exist due to inert pair effect is PCl5, BiCl5, SbCl5 and AsCl5. This question was asked in GATE exam 2010. First, let us see what is inert pair effect. Let us take boron as example. The electronic configuration of boron is 1s2, 2s2, 2p1. This is the first shell, this is the second shell. The second shell, I have 3 electrons. These 3 electrons, whatever are present in the valence shell, can form bond with some other atom. We get the compound. For example, let us take BF3. Boron has formed 3 bonds with 3 fluorine atoms. That is possible if all these 3 electrons involved in bonding. Consider carbon. The outermost shell, I have 4 electrons. All these 4 electrons can be used for bonding. The boron group, the next atom is aluminium. Aluminium also can form +3 oxygen state. Here I have silicon that also can form +4 oxygen state. That also can form 4 bonding. Boron, aluminium, gallium, indium, thallium. This thallium will be after the transition metals. Similarly here, carbon, silicon, germanium, tin and lead. This lead will be after the transition metal. I have also nitrogen, phosphorus, arsenic, antimony and bismuth. Here I have oxygen, sulfur, selenium, tellurium and polonium. Thallium, lead, bismuth and polonium, they are in the same period and they will be after the transition metals. The expected oxygen state for is +3, for lead it is +4, for bismuth +5, for polonium it is +6. But in the case of thallium, say for example, the outermost electronic configuration is like this. The 2 electrons, whatever are present in the ns orbital, will not make bonding. Only the electrons, whatever are present in the p orbital, will involve in bonding. So oxygen state will be only this. These 2 electrons will remain as such. As lone pair of electron, it will remain. That's why it is referred as inert pair. Similarly, in the case of lead, the electrons, whatever are present in the s orbital, will remain. Only the 2 electrons, whatever are present in the p orbital, that will form bonding. That is referred as inert pair effect. For thallium, you can expect +3 oxygen state, but it is more stable in +1 oxygen state. What is the reason? I mentioned these elements are after the transition metals. The transition metals, the electrons are added to the d orbitals. The shielding will be poor for d electrons. This is the reason. Because of that, the effective nuclear charge increases. There will be more number of protons that will pull the electrons, whatever are present in the outermost shell, more strongly. Since the shielding is very poor, the effective nuclear charge increases. The force of attraction between the nucleus and the ns electron will be very high, since the shielding is very poor. Since the force of attraction is more, these electrons cannot involve in bonding readily. They remain as such, they remain as lone pair of electron. This is referred as inert pair effect. Generally, it is exhibited by thallium, lead, bismuth and polonium. I can ask this question in different way also. Which compound is more stable in +1 oxygen state? I can give B +1, Al +1, gallium +1, indium +1, thallium +1. Thallium +1 is more stable in +1 oxygen state. Boron is more stable in +3 oxygen state. This is because of inert pair effect. Similarly, lead is more stable in +2 oxygen state and carbon is less stable in +2 oxygen state. Here, bismuth is more stable in +3 oxygen state. +5 is not possible for bismuth. So the correct answer is BiCl5. This is not possible. This cannot be formed. Due to inert pair effect, BiCl5 cannot be formed. What about SbCl5? In fact, in that there will be some inert pair effect. But compared to bismuth Cl5, it will be less.